Sample problem 1013. In 1999, the FDA, the Federal Drug Administration, approved the use of nitric oxide, NO, to treat and prevent lung disease, which occurs commonly in premature infants. The nitric oxide used in this therapy is supplied to hospitals in the form of an N2NO mixture. Calculate the mole fraction of NO in a 10.00 liter gas cylinder at room temperature, 25 degrees Celsius, that contains 6.022 moles of N2 and in which the total pressure is 14.75 atmosphere. So we're going to find the mole fraction of NO. So the mole fraction, the symbol for it is the X. We're doing it for NO. So the mole fraction of NO would be the moles of NO divided by the total number of moles. So that would be the moles of NO plus the moles of N2. And we know the moles of N2 is 6.022. So we know that that can be expressed as the moles of NO divided by the moles of NO plus 6.022 moles of nitrogen, right? Moles of the substance you're interested in divided by the total number of moles. So we just need to find the moles of NO, and this is a pretty straightforward ideal gas law. They tell us PV equals nRT, right? We want to find the moles of NO, so that would be PV over RT. So the pressure is given, 14.75 atmospheres. But now, think about this. That's the total pressure. That's not the pressure of NO, that's the total pressure. So we have an issue here. How do we find the pressure of NO? Well, let's come back. P total is 14.75 atmospheres. And according to Dalton's law of partial pressures, that's the pressure of NO plus the pressure of N2, right? So let's find out what the pressure of N2 is, because we do know how many moles there is. We know there's 6.022. And there's 0.08206. I'm going to leave the units out here because we're running out of room here. So there's your R, and then your T, they tell us 25 degrees Celsius, so that's 298.15 Kelvin. So nRT divided by 10 liters. Okay, so that's going to give us the pressure of N2. Once we get the pressure of N2, okay, we'll have an answer there. The pressure of NO is the total pressure minus the pressure of N2. Okay, so nRT over V is the pressure of N2. So let's see if we can remember. I can remember these numbers. nRT, so 6.022 times 0.08206 times 298.15 divided by 10 liters. So it looks like 14.73. So it looks like the pressure, the partial pressure of NO is 0.02 atmosphere. Now we can come back up here and do this calculation. 0.02 atmospheres. The volume is 10 liters. The gas constant is 0.08206. And our temperature is 298.15. So that'll give us the partial pressure of NO. So 0.02 times 10 is 0.2. So 0.2 divided by 0.08206 times 298.15. And it looks like it's 0.00817. So there's our moles of NO. Okay? So now to find the mole fraction, it would be the moles of NO So the moles of NO divided by the total number of moles. Okay? So we have that one. So divided by 6.022 plus 8.17 times 10 to the minus 3. And it looks like it's really, really small. 0.00136, so 0.0014. What that means is the moles of NO divided by the total number of moles is 0.14%. Remember, if you wanted to convert that to percentage, you would multiply it by 100, and that would give you 0.14. So 0.14% of the total gas is NO. The rest of it, 99.86% of it, that would be the nitrogen. It's almost all nitrogen.